All right, hello everyone, which is just me for the moment. But uh, this is Ted, and we are making a game from scratch on a Mac, hopefully. Um, I'm just gonna kind of I'm not gonna really wait for anybody to join, but what I've decided to at least attempt to do as an experiment is run this as a live stream. So it's going to be Saturdays at 11 o'clock Eastern Time. I'm going to try this a few times, see if it works. I'm not so sure if it will just because internet connection here isn't great. We're supposed to get fiber, I think, by the like sometime in the spring. So that would dramatically improve it, and then I won't be like fighting my spouse over it. So we'll see what happens. Either way, I'm still going to post this to YouTube. So if you missed it or if the quality wasn't very good, you can still get it on YouTube. So we'll just kind of go from there and see what we can do. So where do we leave off? We left off, I believe, with something like the ability to. Let's see. I think we had something that was like, yeah, it would take a it would take it would draw like multiple colored rectangles, if I recall correctly. Yeah, okay. So we could sort of draw these rectangles, these squares, or basically any kind of rectangle. And the way that we can do it is we can use some different coordinates, and we can then have some colors actually that are drawn based on those coordinates. So let's like hop right into the code, and I'll show you what I mean. So if we're going here, the code, right? What we've got is this draw rectangle thing, and what we're doing is we're literally passing it at like the vertex buffer, and it's just drawing straight into the vertex buffer. That's okay for now. Usually in a more sophisticated game engine, you would kind of do this later. You would have a separate sort of a function that writes straight into the vertex buffer. There's some pretty good reasons for that. I can kind of show you that at a later time. But if we see this draw rectangle, okay, function, now it's getting called in two different places, and we're drawing, these two rectangles with what is a minimum x and a maximum x, and then a minimum y and a maximum y, right? And it's a similar thing here. So it's minimum x, maximum x. Now, typically what I start to do, and what a lot of people, this is kind of this notion of sort of like bottom-up programming. You may notice, or you may have noticed a certain pattern or a certain structure that's kind of inherent to this sort of drawing function, right? So one thing you might notice is, gosh, it really does seem like every time we've got a minimum x, right, we also have a minimum y. And every time we have a maximum x, we also have a maximum y. It kind of seems like these two things are like, I don't know, like together, like structured together, kind of in a similar sort of a way. So if things very frequently occur together, or very frequently are passed together into a function, then it starts to become apparent that there is like something there, and that we can start to create more of a structure that represents what that thing is. And in this case, it may not be. Now, another thing too is this is not always apparent right away, and what I tell people and what I kind of tell myself a lot is don't force it. So you might go a long time kind of copying the same stuff over and over and over again, and it may not, like, the actual pattern may not occur to you for a while, and then kind of that's the time where you say, oh, okay, yeah, for months and months, or maybe for weeks, I've kind of been doing this, But now I notice that there is a pattern, that there actually is something, things are kind of commonly done together, or something is done very frequently together. And then you can start to create sort of more of a structure out of it. So I'm not saying you always have to kind of go into this way of doing things. A lot of times what ends up happening though is you just, like after a few weeks, you kind of get tired of, oh gosh, every time there's a minimum X, there's a minimum Y, like I have to do all this copying of stuff. It would be nice if I had like a little convenience thing where I could, you know, just pass them together or something like that. Or if there were some kind of a concept that represented these things together. And that concept, surprisingly, not, unsurprisingly rather, is, you know, a vector. So we could call this a vector 2. I like the idea, you know, you could call it a v2, right? This is what Casey calls it. So, and all it is it's just got, you know, R32, minimum X, and minimum Y, or well, just min and max actually. That's all it is. Yeah, not it has no concept of maximum or it's got no concept of X or Y. And so all of a sudden this function here changes, right? So it becomes some, instead of passing minimum X, minimum Y, what we do is we pass, you know, v2 min and then v2 max, right? And now the cool thing here is we can actually, if this is all you did, what you could do now is you could just compile the source code, and then you could just follow the compiler errors until you have fixed everything, and that would actually work just fine, right? So there are a few things we probably notice though right now. So instead of well, actually, wait a second. No, right, v2. We're not doing it that way. We're doing v2 min x, right? Wait a second. Yeah, v2x, right? Yes, v2x, and then v2y. So anyway, yeah. So then we do x dot min, y dot min. Okay. So this changes to x dot min, right? And this changes to y dot min. And so on and so forth, right? Wait, that was max. So you can just, you know, just paste things here. Right. And then now the way that you specify things is going to kind of change a little bit too. So that changes for sure. Oh, come on, Windows. I got a Windows computer right next to me, and I'm just using it to check if there's anybody currently in the chat. So we have this now, and so that's just a fewer parameters that we can pass in, and it's maybe a little bit more tight. So now we're just going to create one of these, you know, these different vectors. And I think there's like some fancier ways to make them. You can have functions that kind of just like constructor functions that create them. So one thing we might do is we might say v2x equals, you 0.0f, 0.0f. And then we could just say x, right? Well, not what I wanted. I'll just type it in. And then a similar thing with y, right? So we could do that instead. So now, for this next one, y is actually going to be equal to, x is going to be equal to 128, right? So we can just copy that in here. Oops. Okay. And then y is going to be equal to 256, 256. So actually we could do this. I probably don't use Vim as optimally as I could. I'm and I recognize that. It's funny because it's like half the time my mind is like thinking, okay, I could like spend my time on, like really like cleverly thinking about what command I need to do, but then sometimes like the burden of thinking about what to press is like bigger than just doing the easier thing, and then I just end up doing the easier thing. So now this should be exactly the same, right? We should expect this to be the same. So if it is the same, let's build it. Oh, okay, so I guess we can't make things that way. That's okay. So we can just do something like this instead. I'm not the greatest at like fancy syntax, so a lot of times I think it's just because I don't really care. Ultimately it doesn't really matter if this has like convenient syntax. So the point is, it's simple and it's something that you can understand, right? That's the only thing that matters here. Pretty much everything else is just there's a big culture in programming circles about doing everything on one line, or using things that are like really short. I just don't think that that's really that important. So we'll just do kind of what works here. There's probably some fancier language features that let you do something else. Okay. So this ought to give us what we want. Now you might be thinking, gosh, that seemed like a lot of work for minimal benefit, and you're probably right. But it will allow us to kind of, what? Okay. Oh, because I didn't declare y. Right. That's fine. This does seem like it's taken up more, a little bit more space, but that's fine. Okay. All right. Another compile error. All right. So now we should have no problem there. Okay, so now I built it, and we're going to run it again, just to make sure that nothing really changed. Oh, you got to be kidding me. Happy Saturday, my friends. What is going on here? All right. X min, X max. What could be going on? E2y. Draw rectangle. Okay, so we know we've got nothing changed there. Man, I really should not have started with like x dot min, x dot max, y dot min, y dot max. Well, why would this not really draw quite? Now this is kind of where we can start to use the, I really don't know why this is not doing what we want it to, but let's see, we start with 0 for the max. Is that what we had? No, that's not what we had, I think. Oh, wait a second. Yeah. I think somewhere along the line yeah, this is clearly wrong. Because the maximum x should be 128, right? And then y starts out at 0. All right, so I mean, a lot of times people will be like, oh, well, you're going to introduce bugs if you do this. It's like, well, yeah, but at the same time, like, they can be pretty easily fixed. So now, yeah, because x goes from 0 to 128, right? That's the maximum. Y goes from 0 to 128. That's for the first one, and then the next one is going to be x goes from 128 to 256, y goes from 128 to 256. So, duh. All right. That should be pretty easily fixed now, and it should be exactly the same thing at this point. So, this is kind of the way I do things. I break stuff a little bit, and then, okay, yeah, there we are. So that's the same thing. So that's good. We've kind of introduced this idea of a vector. That makes it a little bit more simple when we pass things into this draw rectangle thing. Now, what gets kind of interesting is, okay, well, what if, a lot of what we're going to want to do, I think, is have some notion of like a center point, right? So what might that be if, like, what if we had some kind of, like, what if we had something like that's like a player character or something? A lot of times what you'll have is something like a center point on something, or some kind of a coordinate system, right? We sort of have a coordinate system here, but we don't fully have one yet. We don't have some idea of like, okay, something exists in this coordinate space, and we can then move him around in this two-dimensional coordinate space, right? What we have are vectors. We've got things that are like where a rectangle is defined as, just like a two-dimensional vector. So like, x going in one, x goes in one direction, or y goes in another direction, or like something can have like a minimum value and a maximum value, right, on any given axis. And that's just a convenient thing to do. But here, like, what if we wanted to have some notion of a player, right? Well, a player is kind of like a rectangle that's defined by, so like, let's say that the first rectangle that we're drawing is the player. Like, pretend that this first rectangle that we're drawing is just the player. Okay, so what kind of properties would a player probably have, or like some kind of a game character in a two-dimensional world have? What would that thing have, right? That's what you want to think about. And one of the things I would think is that that thing should have something like a width and a height. So we're definitely going to do something called player width, right? And let's just say that the player is, I don't know, let's just say that he's 24 pixels wide. And we can always change that, of course. And we can also say the player is 24 pixels high, right? Now, there's also some notion of what's what's the player's x coordinate? So we could define that. We could say player x coordinate, right? Let's say that the player is at x coordinate, I don't know, 100, right? And let's say that the player is also at y coordinate 100, right? So that's where the player is located. Now, just for the purposes of this little fun test, or like this thing, I'm actually going to just comment out our other. Well, I think we'll just, for the moment, let's get rid of our second draw rectangle command, because now that we know that we can draw extra, draw more than one rectangle, we just know that we have that. That's a nice thing to have. But what we're going to do now is we're going to start to take these ideas of width, height, x and y coordinate, right? And then we're going to turn that into a rectangle draw command. So how does this become something where we can then take these properties that represent the player, right? And then turn that into rectangles that we can then draw on the screen, right? So the player width and the player height, those are constants, right? Almost certainly, unless you have a game where like that's changing. That could change. It's just not very common. Now the x and y coordinate, that is almost certainly going to be changing all the time in pretty much any game, right? So if we wanted to have, say, like an x coordinate and a y coordinate, if we want to change that, then we want to basically draw that in some different place. So if we're going to draw if what we're going to do, let's just pretend now that these are both 0 again, right? Okay, so both the x and the y are 0. And now along the x-axis of where the player is, right? So if I'm drawing something like, I don't know, I guess I'll open up Sketch. That's currently my best. Part of me wants to do some of these on the PC too, because my PC is way better than my Mac. I've got this kind of like older iMac. It's good. It's just these aren't as fast. So anyway, let's just pretend that this rectangle is like coordinate space or whatever, and let's pretend also that this other rectangle is like a player character, right? And so like maybe the inside of it is blue, kind of like what we wanted to do, right? Or I don't know. Blue is fine, right? So like let's say this is the player, right? Okay, so the player is going to kind of be in the space here, and you've got this kind of like center point in the player here, right? So the center point is where the player is on the x-axis and on the y-axis. Now the start of where we're going to draw the rectangle for the player, though, is actually it's actually back. It's back on the x-axis, right? It's back by half of the player's width, right? So where we're starting is we're going to take the coordinate that represents the center point of the player, and we're going to move back half of the player's width. So that's just some pretty simple math. So what this is actually, it's actually just player x coordinate, right? Minus 1/2 times player width, right? And now you can do the same, yeah, so, all right, so that's where that rectangle starts, right? And now, well, where does the rectangle end? Well, it's the same thing here, except it's going to be plus that amount. And there's a lot of different ways you can do that, but this is just a really simple way of thinking about it, right? So, okay, great. So that's what it is on the x. And basically, if we look at this now, with our coordinate system kind of defined the way that it is, I believe it's defined where, well, actually it may be defined, no, I'm thinking here. I think this is 0, 0, right? Where down here is like 0 on the x and on the y-axis. we'll find out as we play around with it. We may need to actually like invert the y-axis of our coordinate system, because if we don't do that, then we'll end up with a situation where, well, it's a lot more intuitive if to us human beings, where we live on a planet that has gravity, and gravity pulls things down, so we understand usually that like down is negative, right? So a lot of this is just to kind of create something that is intuitive to human beings for the most part. But it really depends on your game. Some games can have something that they can have a coordinate system that's, maybe you're doing like a Zelda style game where the coordinate system is going down on the y-axis. Maybe that's positive number. So it might not actually matter, but still, I think even then, even if it was top-down perspective, people would probably, it's probably more natural for people to think that down is negative on the y-axis. It's what we're taught in school too, like, when we're taught math, that's basically what we're taught. So with all of that said, let's put in the math for the y as well, right? And so that's just going to be the y coordinate, right? Minus 0.5 f times player height, right? And the max is going to be the same thing plus half of the player height, right? Cool. So this ought to draw us a thing that's 24 by 24 at approximately like 100 and 100. So let's play around with that and see what we get. Should build. Okay, so it builds. All good things. Now let's play it and run it. All right. So yeah, that's a good, see that position there. So as predicted, 100 over on the x is there, and then 100 up on the y is there. So this is behaving kind of as we would expect, right? So now the question is, given this understanding of things, where do we go from there, right? So what is a game? So that is kind of what you're asking me, right? So what we have now, believe it or not, with the ability to, because what we can do is I can change this, right? And so I can say, okay, well now it's 200, right? And then I can recompile it, and then we'll get the guy in a different place. Now, obviously, it's not much of a game if we have to recompile it every single frame, or every time we want to like have it do something different. That's probably not a very good game. I think you could probably do much better than that. That said, so yeah, now he's at 200, right? So what we want to do actually, because basically what every game, pretty much, what is a game? So let's just quickly talk about that, because we're actually at that point now where we can talk about that. We can say, what is a game? Okay. Now, a lot of people have a lot of different ideas of what a game is, and I don't really want to kind of like debate the more, the newer sort of points, or the newer, like, I don't really want to take like some fancy postmodernist take on what a game is, because if you look at kind of how old games are very, very old. We've been clearly playing them since, ancient times at the very least, if not much further back. Um, we have board games, we have all of these things. Only recently have we had things that we call games that are more like a story or more like a walking simulator, and that's an interesting thing. But I don't think it really fits into like the mainstream definition of what a game is. But as I understand it, and what I think the most effective way to understand what a game actually is, it is you take some input, right? So we have input, and now where does this come from? Well, input comes from a lot of different things. So let's imagine that we're playing, I don't know, we're playing checkers in the Roman Empire. I don't even think they had checkers back then. But yeah, let's pretend that we're just playing checkers in physical reality, right? So the input is is players' hands, like picking up checkers pieces and placing them somewhere, right? So the input is actually, it's a physical system, right? So there's stuff that physically exists in the world, and you're picking it up. Your input into the game as a player of checkers is to pick up one of your checker pieces and then place it somewhere else, right? And where you place your checkers piece is either an accepted move or it's not an accepted move, and that gets us to the next thing. So you have input, and then you have state, right? So what is state? Well, state is in the physical world, state is just, well, it's no different really in computers too. It's just that the state is kind of, it's modeled a little bit differently, it's represented a little bit differently. But let's go back to talk about checkers, right? So checkers, if we're just playing that game, the state is the physical objects on the board, right? So we're talking about you have red pieces and black pieces, and you have spaces on the pieces on the board, and you have places where you can put the pieces. So I can pick up a black piece and I can place it on a tile, right? So there's that state is a physical thing. Technically speaking, I could just throw all the chips right on the board in a big pile, right? That's a state. That is something that we would consider a possible state of checkers. Is it a valid state? Well, no. It's not a state that conforms to the rules of checkers. There isn't really anything about that game that allows or that has to do much with just this big pile of checkers pieces. And well, why? The reason is because I think it would be difficult to get human beings to agree on what to do with a big pile of random pieces, right? It's not something that we can really process as a game. So let's think about that a little bit more. So you have state, and then you have rules, right? There's rules that something needs to conform to. So in the game of checkers, just as our example, we are allowed to place pieces on the tile board, right? We have a board of tiles where you're allowed to place your piece on a discrete tile. You can't place a piece in between a tile. That's not really something that is understood, or that's not really something that is allowed. You can't have a piece that's intermediate, in between one tile and the other. It needs to be discretely on a tile. Okay, that's a rule. All right. Another rule is you may only move your piece one ahead, right? So that's a rule. I can take my black piece and I can move it into an empty tile right in front of me, right? That's a rule. Another rule is if there is another piece in a diagonal tile that's next to yours, then you can or actually I forget what the rules are exact. I think yeah. So if there's a piece that is directly in front of your piece that's of the opposite player's team, then you can jump your piece over that piece onto the opposing tile, and then you can take that other person's piece off of the board, right? So that's a rule. You can't go backwards. That's a rule. You can't move backwards a space. That's a rule. You can't take your piece and place it onto another tile that's also occupied by one of your pieces, right? So that's a rule. And so there's actually, if you just take a simple, even what's considered a simple physical game like checkers, and you say, okay, gosh, like, if you just sit down and this is a fun exercise, especially as a game designer, just take a lot of games that you know or that you play or that you're used to, and just sit down and just list all of the rules, and you would be surprised at how many there are. A lot of games that are just supposedly simple games actually have a lot of rules in them. And it's a very useful exercise to just enumerate all of those rules, because a lot of times what you'll realize is, okay, let's say I want to design a new game, right? Well, the core of that game, right, is a list of rules of what you're allowed to do and what you're not allowed to do. And the interesting part is what sort of arises naturally as a consequence of those rules. Any kind of a game that doesn't have rules is just really not much of a game. There really isn't much to explore there. There isn't really much that's all that interesting about it. So in any kind of a game, what there is that you get input from the player. So in checkers, we have input by you moving a piece. And then we have state, which is just the physical pieces on the board. And you're allowed to manipulate the state through your input, through your hands, right? And then we enforce rules on what you can and cannot do with your pieces. So if you try to move a piece all the way across the board, then the person that's playing with you says, not allowed, you can't, that's not one of the rules of checkers. So there's some kind of enforcement of the rules. Now, on a computer, this is quite a bit different, right? So where does the input come from? Well, the input comes from various devices that are connected to the computer, or it can come from onboard components in the computer itself. So if we're talking about a game console, well, the input comes from a game controller, right? Typically. It can also come from other connected peripherals. So it could come from like a keyboard like this, or it could come from a mouse. It could come from like a Microsoft Kinect device. Like it could come from the Power Glove, whatever thing you can imagine. Okay, well, what is the state? Well, the state is just, if you really think about it, it's actually just a big block of memory somewhere on the computer, right? That holds all of the different variables that represent what's going on in your game world. So if we actually go back to this game right here that we're playing with, right? What's some of the state in this game, right? Well, so far, the x coordinate and the y coordinate, that's state, right? Where the player is, that's state. And we could make a game out of this by making it so that the input from the keyboard can manipulate the state of the player, where the player is located, right? That's something that we could do. And what would happen then is, let's say that you press down a key on your keyboard, right? Let's say you press down the up key. Well, and that input then will manipulate the y coordinate. It'll move the player up, right? So that's something that you can do. That would be something that you could do, and you could manipulate the state. You're kind of creating a simulation by doing this, right? You're simulating some state that is located somewhere in memory, right? Because if we declare these different variables, right, for player x coordinate and player y coordinate, basically what we're doing is we're telling the compiler is going to take this language here, and it's going to convert it into assembly instructions, and somewhere in memory these variables are going to exist, and they're going to be pulled from memory, and they're going to be put in registers, etc. The system is going to manage this state in memory. So that's actually what's going to happen. And then we can enforce some rules on player movement. So what are some rules that we could enforce? Well, I think one sensible thing that we could enforce is you can't go past the edge of the screen, right? That's a rule that we could enforce. If you try to go past the edge of the screen, we're going to stop you, right? That's like a rule. If another possible rule that you could have is if you try and go past the edge of the screen, we'll just wrap you right around. That's another rule that you could enforce, right? So we're just kind of like starting to build up this vocabulary of what a game is, and we can run this with the magic of computers and just how extraordinarily fast computers are. We can actually run this simulation 60 times a second. We can simulate an entire frame like 60 times a second. That's pretty cool. So there's just kind of this enormous possibility here, just out of something as simple as this. So I didn't want to go too much into game design today, actually, and I just wanted to get you kind of some idea of where we're taking this. But basically, to turn this thing into a game, we need to understand what the sort of changeable state is, and we need to pull that out, right? So what I think we're actually going to do is we're going to say, you know what, player X and player Y, just for the moment, just because it's something that we that we're using, we're going to make these global variables, and we can use the static keyword to do that. I think Casey also does something like we'll change it as well at some point. So now with these are basically global variables at the global scope. Eventually, we're actually going to have a much more fancy kind of way of managing all the game state. It'll be like we'll allocate our own block of memory. We'll sort of like reserve our own memory for it. But this, I think, is actually like a better way of thinking about it. So one thing that we could do, just to show you that we can manipulate the state, right? What we could do is we could say, okay, what about on every frame update, because remember this draw and MTK view thing, this gets called 60 times a second, right? So what we could say is player X coordinate plus equals 0.1 F, right? And we could say also similar for the Y coordinate, right? So this is just going to kind of slowly move the player, right? On every frame update, we're going to slowly move the player. And then what we can do is we can say if X coordinate is greater than the screen, basically, because we want it to, be then set it back to 0, right? So like wrap around. And we could do the similar thing with the y coordinate, right? So then that would just wrap around. And so all we're doing is, what I'm actually just kind of want to show you that's so cool is, you can't see it because we've only ever drawn just one frame, right? We haven't actually tried to animate it. But this thing is actually running at 60 frames a second, and it's it's like it's a full game. So that's pretty cool. So let's just build it, and you'll see. Assuming that we can. Okay, good. And I really need to figure out. I wish that this would just stay open. It's maybe just like an annoying thing about Apple. I want this to just stay open on my game, and I can't. Okay, can you see it? Now what we've got is a very, 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 very slowly moving square, right? And it's moving at like 60 frames a second. Now, what can you do with this? Well, there's a lot you can do. The more interesting thing, I think, because right now, right now what this is not a game, right? What this is it's more, I would be inclined to put it more in the category of like a simulation or an animation, right? And the reason is because it's got everything except for the input. It's got state and it's got rules, but it's got no input from the player, right? So it's just got, the state is the location of where this blue square is, right? And the rules are every frame update, move it 0.1 f in the x direction, right? Something like that. And every frame update, move it such and such in the y direction. So actually I wonder, will this crash? I don't think it'll crash if we try to. I kind of am curious what it'll do on the edges. It might do something funny in the edges because we haven't thought about it, which is certainly a thing that can happen. But yeah, so it's got state and it's got it's got two out of three of these things, right? It's got state and it's got rules, but it's got no input from the player. And so the next thing that we're going to be working on is hooking up the input so that you can move this square with your keyboard, right? Now that's a very basic start to what a game is. Obviously games are in reality much more sophisticated than that, but it does kind of give you something. Okay, are we going to crash here? I'm curious. What happens? Okay, in our square, did you see that? Our square totally wrapped around. So there you go. That's kind of cool. So as I was saying, we've got a lot of the building blocks here of what a game is, but we're missing we're missing the other important part, which is input. So we're going to be on the next section. We're going to hook up the keyboard so that when you press keys down, it modifies the player coordinate or the location of this square, right? And then that gives us the beginnings of what a game is, because then we'll have all three of those things. We'll have input, some kind of state update or state manipulation, and then some rules that the update has to follow, and then ultimately at the very end we're going to render. So let's just touch briefly on, I've said what is a game, right? And now we might ask a similar question. Okay, well, what is a game engine? What are the things that a game engine does, right? I don't really like the term game engine because I think I saw at one point it was a great talk. It was a talk on it was someone from Nintendo at DigiPen said this, and I totally I just thought it was a great way of putting it. Um, the way that he put it was, uh, I don't make game engines. What I do is I make games, and the thing that's left over after I've made a game is the engine, and I can use the engine to make other games, right? So in the process of making a game, I ended up building all this infrastructure, all this stuff, and then I had it left over. It is kind of like, I don't know, I made a casserole and there were leftovers, and maybe I learned a few things about making casseroles that I could then use to make a different casserole later on, and that's my casserole engine, right? Something like that. So a game engine is really, it's just code for a game. It is a game, but it does a few things, right? It has some way of gathering input. It has some way of simulating state. It has some way of enforcing rules. And then typically the extra thing you add on there is, which is is one of the most important parts, rendering. So we render the result, right? We render the result of the state manipulation. So we have, and that's kind of what's going on here. So we have state, which is like the player's position, the player's width, and height. The rules that are enforced is he's going to move this much every frame. And then what we're rendering here is, well, we're rendering the background color, this green color, and then we're also rendering this blue square, right? So we're drawing this blue square once a frame, right? So that's actually what's going on here. We're doing some drawing. Now, obviously, in a more advanced game, the rendering part is going to be very, very sophisticated. It's going to be like a three-dimensional scene, and there's characters, and there's lighting, and there's all this stuff going on. But at a very base level, ultimately, a game engine does these kinds of things. I've also talked about visual rendering, like drawing stuff, but rendering can also represent other sorts of output that are human perceptible, right? So we could be talking about audio, right? So human beings hear things too. We listen. So sound rendering is very important, and we will certainly be working on an audio mixer or an ability to render audio on the Mac platform and on other platforms. So that's also a very important part is audio rendering. But you can imagine as we develop more and more sophisticated technologies, what rendering starts to mean. It can mean a lot of different things. For all we know, somebody might be able to use a computer to render smells, or to render, in VR, we're not just rendering one picture that you see, we're rendering multiple pictures, and we're sort of like we're overlaying them stereoscopically, right? So that's another kind of rendering that you could do. You could have like touch rendering or like kinesthetic rendering, and that's like another interesting possibility. So when I say rendering, I don't mean I don't just mean drawing stuff on the screen. I mean all other kinds of outputs from the computer that ultimately result in something that's perceptible to most human beings, right? So that's usually what I mean. But yeah, with that said, I think it may not have seemed like we made a ton of progress. I know I talked a lot today, but I feel like it's actually good because it has set us up for what's coming next, right? So, no, I do not want to open Slack. I actually hate Slack. Okay, so back to our code. We have moved player coordinates out because that represents the state. And we've seen just how fast this thing is actually rendering stuff, so that's really cool. I do also want to, at some point, do like just a full, maybe once we've got keyboard input, I want to actually go back over this code again, and I want you to have more of a clear picture of just exactly what is going on here, right? Like we. On the Apple side, right? we didn't quite touch on how the drawing is getting queued up. And now that we're actually drawing something that is animated, I wanted to just kind of like walk you through what that might look like, so you just have a better understanding. So I think that's going to be important on the next one. But yeah, aside from that, I think this is a good place to stop. We'll definitely set up keyboard input next time. I think that's going to be a really good place to go. And yeah, I'll see you next time. And if you like this, I'm trying to do it on Saturdays. So it'll just be once a week.